Hi everybody, Matthew Gusdale here for the very last of these Game AI out of the University of Alberta class lectures. Today we'll be talking about AI-based game design. So as a reminder, this has happened, I don't even know, 6 times now? 7 times? There will always be the survey link for those of you in the class. Please go ahead and fill that out, though it should be in the chat as well, linking it now. Okay, so a little background. For those of you, especially those of you who maybe don't remember the start of the semester or weren't here in the start of the semester, I wanted to present this quote and see what year you thought it was, how long ago you thought this was from. Let me read it out loud. Significantly, developers overall reported that AI was becoming a more important factor in game design than it had been in the past, often being assigned an equal priority with graphics and sound in the initial game design and allocation of resources. When do you think this was set up? So this is basically saying that AI is becoming a more important factor in game design than in the past. Now, as a hint, I will say that later on in this article, they talk about genetic algorithms, which we talked about in class during PCG, during the discussion of PCG. And they talk about neural networks, which obviously we talked about both for the PCG ML section and for the deep reinforcement learning section. So the last 2 lectures before this one. Okay? Everybody have your guesses? Maybe put it in the chat if you're watching. This is from a Gamma Sutra article, blog post, from 1998 by Stephen Woodcock. Here's another quote. Everybody thought that game AI would continue to be an important part of most games. The recent advances were unlikely to be lost to a new wave of gee-whiz 3D graphics engines, and the continued increase in CPU and 3D card capabilities was only going to continue to give AI developers more horsepower. So again, let's think about what year we think this might be. Now, I will say that this article talks about how AI is being given up to 25% of the CPU for most games this year, in the year that this article is talking about. Well, this is from Stephen Woodcock again from only 2000. And unfortunately for Steve, the percentage of the AI's processing power, or the processing power of the game given to the AI, rather, went down quite a bit. And in fact, the recent advances were lost to new wave of gee-whiz 3D graphics engines. So the reason why I bring these 2 quotes up is because roughly every 5 to 10 years, for the past 20 years or so, people have predicted that AI has finally arrived in games. That finally, we're going to have game AI be the thing that people buy games for. That it's not graphics, it's not cool new rendering software, some stuff to make things look even better. Nothing like that. It's going to be AI that's the selling point. And that has not been true for 20 years. Now, that doesn't mean that it's going to continue to not be true. And there's, I don't think that means that we should give up hope on the idea that this recent sort of round of excitement around AI should lead us to think that this will never be the case. But I don't think we'll ever get the case of AI being the dominant force. We can certainly give examples, and I'll give examples throughout this lecture, of really cool and interesting things done with AI in the last few years. All right, so AI-based game design. That's the title of this lecture. What does that mean? Well, you might think, does it mean an AI's making games all by themselves? No, that's autonomous or automatic game design. Okay, well, does it mean AI is making games with humans, so like with humans as well, with human game designers? No, that's co-creative or mixed initiative design. Okay, well, does it mean games where the primary selling point is the interaction with an AI system or systems? Yes. Why did it take you so long to guess that? Let's actually first go through and talk about these 2 other terms just to get it out of the way, and because I won't have another chance to talk about them. So autonomous game design. So autonomous game design is basically the answer to the question of what if we use PCG approaches to make the whole game? Right? Not just the levels of the game, not just the guns, the game bits, not just the game story, everything about that game. The most famous example is probably Angelina by Mike Cook. Angelina is technically an acronym, but I don't think even Mike Cook remembers exactly what it is, except that it begins and ends with Angelina, or it ends with Angelina. So it's like a neural game something 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 Angelina. I named Angelina, I think. Angelina basically relied on genetic algorithms as its primary thing. As a reminder, genetic algorithms are primarily used in research PCG, not in industry PCG, or in PCG that's going to be in a game. Here's an example of a Angelina game. The title screen of one, it's called To the Sect, which is a game produced with or by Angelina, depending on who you ask. And these kinds of systems usually are limited to only producing games of one specific genre. So this version of Angelina, there have been a lot, was only able to make sort of like 3D maze collectathons. Other automated game designers have been able to make just platformer games or just arcade-style games, etc., etc. Now, notably, there's a whole video on Angelina and all the different versions of Angelina from AI in Games, Tommy Thompson, which I recommend watching if you're at all interested. There's some really interesting stuff in there. Mike Cook's a very clever guy. More recently, if we want to talk about more recent stuff, I actually was part of an approach to try to instead do this automated game design stuff, but with machine learning. So the idea was that we could learn whole representations of a game. So let's imagine that we've learned Super Mario Brothers and Mega Man and Kirby. Now, if we've learned, say, 3 games, we can now think about those as defining 3 points in a massive search space, which then we can search, right? So we can query a random point in the search space and say, hey, what's this? We can say, okay, that's not a very interesting game. Do a little bit more search. Hey, that might be more interesting, but there's no player, so that's no good. Do a little bit more of a search and find something kind of interesting. Notably, I go into more detail on this in a paper in the Automated Game Design via Conceptual Expansion. So here's an example of me playing this generated game. This generated game was entirely created by the AI, and again, it's a machine learning-based approach, so it learned about these 3 existing games, Super Mario Brothers, Kirby, and Mario. Super Mario's, Kirby, and Mega Man, Mario not twice. And it came up with this kind of interesting little game, right? So all of the rules of the game, all the mechanics of the game, all the code of the game, all the level design of the game, that's all the AI. What I did is I'm playing it right now, and I also colored the different rectangular blobs. And at least it's kind of an interesting game, right? Now, when I showed this to a automated game design researcher who didn't know how it worked, he thought that I'd recombined Mario and Breakout, or Brick Break, from the Atari. But no, that's not what happened. Instead, we have this notion of, or the AI has this notion of the different entities of the game. So what it basically did was it recombined the Super Mario Brothers Goomba enemy, the enemy that you can jump on and squish, with the ground components of all these games, which led to this game where every time you jump on something, it's destroyed underneath you. And it's kind of this interesting little thing. And then we have co-creative and mixed initiative design. So the Tenegra over here on the right, a fairly early example from Dr. Gillian Smith. I'll mention her name a few more times in this lecture, which was a co-creative tool for producing platformer levels. So again, very similarly, this is working together with an AI agent built on some PCG method to produce game content. Again, typically traditional PCG, we're not talking about machine learning right here. Usually it's considered more of a partner than a tool. Like SpeedTree would be more of a tool than a partner, but it's not necessarily that. So SpeedTree still counts as an example of this. And notably, it has all the benefits and limitations of working with PCG, just without the technical knowledge requirements, because that's all been sort of put under the hood, and all you have access to is like this front-end tool, right, with this GUI, this graphical user interface. So similarly, here's a recent example of me interacting with a smart version of Mario Maker that I called More AI Maker, because I have terrible puns. So right now, I'm adding ground to the game. This is for the game Super Mario Brothers. I'm making a little level. I hit end turn, and now this is the agent taking actions. Now, initially, it just adds bricks along the top. It turns out that if you're the AI agent, this is a good starting move. So now what I'm doing is I'm going to fill in these bricks. That's actually going to give the agent a positive reinforcement, positive reward, saying, yeah, that's good. And now I'm going to add this little sort of floating island situation. This is primarily just for showing things off. Hit the intern button again. Let this run again. Okay, so it knows I like bricks, so it adds more bricks, but it also adds a stair up in the sky. Okay, I remove that. By removing it, I've given the AI agent a small negative example. Okay, so here's a second example of this little island decal. So now we're on to 2 examples that I've given this AI, trying to get it to pick up on what's going on. And I actually go ahead and I add this piranha plant as well, so a little enemy to each one. Okay, so here's the AI again, and this time it added a stair on the bottom of the world map. That's not great. Delete that, try it again. Again, another example of this little island, only partially though. Okay. So add more bricks, but it also just added this piranha plant, this ground, this stair, this ground, and this ground right here. So it's not right, but it is getting much closer, right? And this is only with 2.5 examples that it's already picking up these many details. Let's go ahead and keep going. So I delete all of this, which is going to give it, negative reward. And then, I'm gesturing there. That doesn't do anything. It's just for me. I'm going to finish out this example here. Finish this third example totally. Hit end turn. Okay, so it adds more bricks. It knows I like bricks, and it adds 2 ground blocks. So I've sort of cowed it. It's being much more conservative now. I'm going to partially give it the 4th one, and then... Okay, so it added more bricks, but also it added this whole section here and this whole section here. So notably, it didn't quite get it right? It messed up the gapping, the spacing between the different islands, but it got all the local positions correct with like 3 1/4 examples. So you might ask, how is this working, right? I should also note that this was work partially funded by Unity. They were interested in exploring, possibilities of AI assistance for building out levels. So that's why we use Super Mario Brothers, because it's a nice generic domain to be working in. So go to the next slide, please. Can I? No? Okay, there we go. So this is actually deep reinforcement learning with an active learning co-creative agent. I know that I said on Wednesday that deep reinforcement learning isn't appropriate in games, and I can think that you can see from that video why, right? It did some really weird nonsense for 3 out of those, 5 or 6 times, or 4 out of those 5 or 6 times that I hit the button. But because this is not in a running system, right? This is something where it's in development, so it's okay if you do some weird stuff. It's more acceptable, right? We can accept the fact that it will occasionally make mistakes, as long as some of the times it produces some useful stuff, right? The basic idea here, right, is that this is the core reinforcement learning loop. The tool itself is the environment, and the deep neural network is our agent. Now, notably, even then, I told you that deep reinforcement learning typically takes longer than the human civilization to learn how to play things. So this is a simpler solution. We're not just trying to play this game. It's a smaller space that we have to worry about. But the other reason why we're able to go so quickly is because this is technically an example of transfer learning. We have an example of roughly 80 people interacting with earlier version of this tool that didn't have a reinforcement learner in it. And the reinforcement learner is basically learning from those examples and then just transferring that knowledge to be able to get to the point where it can adjust to my particular level design style as we go. So there are ways of making this work. This is an example of how you can get deep reinforcement learning to work in games. And literally 3 days ago, March 31st, there was another paper that just came out up on Archive on using GANs and GAs for co-creative level design. So train a GAN on Super Mario Brothers and also Zelda levels, and then use a GA to evolve in that latent space, in that latent vector, and with human requirements or humans human heuristics, right, of what kind of levels they might want, and then create chunks of levels that way. So this is an ongoing and currently developing area. Okay, but you might say the title of this lecture was AI-based game design. So this is actually based on a paper. This lecture is based on a paper called AI-based game design patterns from about 5 years ago with these lovely people. So we have Mike Trainer from American University, Alexander Zook, who at this point, or at that point, was at the Georgia Institute of Technology, my alma mater, but he is now at Unity. He went to Blizzard along the way. Miriam P. Elhadari. She was at Otter Play at the time, and she's now at a university in Stockholm. Julian Tagilius, who's at NYU. Jillian Smith, who at that point was at Northeastern, is now at WPI. Mike Cook, who at that point was at Goldsmiths, is now at Queen Mary College London. Tommy Thompson, who was at the University of Derby and now is a YouTuber. He's the AI and games guy. That's not entirely fair. He's actually doing all kinds of stuff right now, including just working as a consultant for people interested in doing cool stuff with AI and games. Brian McGurko at the Georgia Institute of Technology. John Levine, who's at the University of Strathclyde. Notably, the only one of these people who I do not know. So I should say I'm somewhat biased in talking about their work because I'm friends with the majority of these people. And then Adam Smith, who at that point was at the University of Washington. He's now at the University of California, Santa Cruz. Okay, so their definition of AI-based games were, an AI-based game is one where the mechanics, dynamics, and aesthetics of the game are deeply linked to the AI system, or systems, I should say. There's the full version of the paper you can read here. It's an interesting rundown, though at this point it's a bit out of date because it, again, is from 2015. So here's another way we can think of it. You might be familiar with the phrase physics-based games, which are basically games that rely on physics systems to show off, to showcase what's going on here. You can see interesting stuff like the Portal games would be an example of a physics-based game. Half-Life 2, an example of a physics-based game. Or I guess the new Half-Life 2 Alyx, or Half-Life Alyx, whatever they ended up calling that thing. Where a physics-based game relies on physics system, an AI-based game will rely on AI systems. Now, notably, so I searched physics games on Steam, and I got roughly 200 results. I searched artificial intelligence on Steam, and I got 1 result, which is not very good. Now, notably, this is a search from a few years ago, and it's slightly better now. I'm using this search from a few years ago because it's very extreme to go like, oh, 200 to 1. Wow. But, it's gotten better since then. The other word in that title was design, or the other words in that title were design patterns. So Christopher Alexander was an architect who came up with a notion of design patterns, which were basically sort of templated designs for buildings or particular parts of buildings that would solve certain architecture problems. And they got adapted into software engineering, where there's specific kinds of design patterns in software engineering. So things like the MDA framework, right? Things like that, which will tell you how you can go about solving certain kinds of software problems. Since that point, where they sort of made the leap from architecture to software, later on they made the leap from software to game design with Bjork and Halopenin. And in this book, they go over hundreds of patterns of game design to describe things like asymmetrical gameplay, cutscenes, high score lists, enemies, etc. In general, I don't think that this book is worth getting if you're interested in learning to make games, but it's really helpful for talking about games and thinking about games. Okay, so AI-based game design patterns. In the paper, they basically identified 7 AI-based game design patterns. These were ideas they had about how you could integrate an AI closely into a game design. So these were things like AI is visualized, where the sort of purpose, the point of the game is to observe or react to the AI's state. Then there's AI as role model, where the purpose or a big portion of the game is about imitating and learning from the AI. AI as trainee, sort of the opposite, where your goal is to teach an AI how to act. AI is editable, where the major portion of the game is about editing the AI, so making changes to the AI. AI is guided, which is about guiding or managing the AI. Notably, you're not training it, but you are guiding it. So you're helping it around, but not telling it what to do or teaching it what to do. AI is co-creator, which is about making artifacts assisted by the AI. Now, notably, This is very similar to co-creative game design or mixed initiative game design. So we've already given you some examples of that one. AI is adversary, which is basically like a typical enemy AI role. Oops, I was off by 2. AI is villain, which is basically an adversary but with drama. That's not quite fair. It's basically a bigger version of an adversary, a more important version of an adversary. And then AI as spectacle, where the purpose of the game, what players want to be doing in the game, is just to be observing the AI. Okay, so there's these 9. Now, don't worry too much if it's not exactly clear what each of these is doing. We'll be going over each of these in a little bit more detail in just a second. So, many example games are actually going to have several of these patterns. There might be a question then of what does it mean for a game to have a pattern, like to actually have one of these patterns? How do you know, especially in the case where some games are going to have several of these patterns? Well, the way that you can think about it is that the game would not be the same game without that pattern for some players. This doesn't mean that all players have to run into it, that it has to be important to all players, but some portion of the players may never interact with the pattern. But for some players, the game wouldn't be the same without this particular thing. Okay, so let's start with AI's Visualize, the first of these. So this is an example from the game Third Eye Crime, which came out in 2014. And as you can pretty clearly see in Third Eye Crime, you can directly see the observed area of the AI guards that you're trying to avoid. It's sort of like a stealth game, as you might guess from the crime. The idea here, the third eye portion, means that you can have a psychic ability to basically know things about your enemies, which they use as an excuse to allow you to actually see visualized things about the enemy's state. And then you can use that to be able to plan out your heist. More recently, in 2018, there was the game Into the Breach. Now, Into the Breach is basically like a puzzle mech fighting game where you command a small squad of mechs, these little brown fellows, or brown and green, who can say, who you're trying to fight off these sort of insect monsters from. Now, notably, the game tells you what the insect monsters are next going to do. Always. It always tells you. There's no stochasticity. So it's going to tell you exactly what their next action is going to be. And this is a turn-based game, which means that you have sort of infinite time to then plan out what your move is going to be in order to minimize the hurt that these evil little buggos can possibly wreak upon your civilization. Notably, the same group also made Faster Than Light, if you're more familiar with that game. So, AI is visualized. Now, notably, what this basically means is that some subset of the AI internal state has to be observable to the human player. I use observable here instead of visualized or visible, as there might be games, right, where instead this would be an audio cue, right? Or maybe something with, like, if you're playing with a controller, some controller rumble. So the controller would vibrate some depending on what was happening in the AI's internal state in order to express that to the human player. So it doesn't matter how it's expressed, just that it is being expressed to that human player. Play is then going to arise from how the player utilizes this additional information. So how this information about the AI's internal state impacts the player's decision making. So there's another example here of the grunts from fear guards, which we talked about earlier in the semester, where these fear guards, which are using a fairly complex planning-based approach, say their plans over the radio, which lets the player figure out what they're going to be doing and plan accordingly, which is actually a game design solution to this game AI problem of the plans making the enemies seem unfun, unfair, and random. So by giving a little bit more information, that let the player know, oh, actually, the enemies are being quite clever. So in terms of techniques for AI visualization, the easiest thing to imagine is to imagine the AI as some single embodied entity, so like a guard, a monster, whatever, something, rather than some abstract other entity like a PCG system or something. Then, if it's just a single embodied enemy, we can visualize parts of its state by doing things like, okay, well, if we want to know its path, we can say, okay, what's the next point in its path, maybe the entirety of the path or the goal of the path. If it's a finite state machine, you could have some information about the current state, what the AI is trying to do, like the entities in Into the Breach. But you could also imagine doing something a little bit more interesting, right? So maybe we could give you something like the transition variables in the finite state machine. So what will cause this AI to move to a different state? Can the player push the AI towards or away from a particular state? There are certain bosses in the game Slay the Spire, which is this card game roguelike, I think is quite good, which do this kind of thing. Or maybe a whole plan. If now we talked about it, that planning approaches are not typically used very often in games. Instead, behavior trees, which can be thought of as like plans where all the plans are pre-authored instead of being generated at runtime. But if we had a planner in our game, we could instead show the AI's next plan or its goal, what it was trying to achieve. So in terms of the impact here on the player experience, it's a lot of things. So novelty is one. Players don't typically get to see the internal state of AI agents visualized, so that's something. Problem solving, so depending on the game design, the information that we get on this AI's internal state can impact the player behavior. Notably, this is a Tamagotchi and this is a sim where we're both getting some notion of their internal state. And player goals. So this information can create or alter player goals. So if, for example, this sim wasn't doing this animation and making this little symbol to show that they were hungry, we wouldn't know they were hungry. But because we know that, we can either try to get them fed, since they just burned whatever food this was, or if we're trying to do a kill all our sims challenge, we can instead, laugh in glee as we are successfully doing our goal. Same thing with this Tamagotchi. By knowing that there's this thing with the state that the Tamagotchi is stinky, we know to clean the Tamagotchi. Okay, so the second one of these was the AI as role model. The basic idea here is that the human player is trying to act like the AI. So this is an example from the game Spy Party, which actually came out in 2018, though this is a earlier beta version of it. Some of these models are not quite finalized. And in this game, there are two players. One player is the sniper, who is trying to kill a spy. The other player is a spy, but the sniper doesn't know which of these characters the spy is, and all the other characters are being run by an AI agent, which means that it is the human's goal to try to accomplish certain spy tasks like planting bugs or engaging in conversation or swapping out statues, without the sniper being able to tell the difference between them and an AI agent being acting according to a finite state machine. So your goal is pretend to be a real AI, right? Now, AI agents exist in this game. It's going to be typically hand-authored for the player to model their behavior. Play is then going to arise from how well the player can model the AI agent's behavior. Now, a big place that this shows up is actually in tutorials. So in a tutorial, it is common to have an AI agent there as an example to the player. This could either be literally just hand-authored, where there's not really any AI, there's no decision-making happening, it's all just stuff that the designer of the game set up, like in Mega Man X, to more recently in games like Overwatch, where they have a very simple AI agent. That's right, there's a tutorial in Overwatch, if you didn't know that. A very simple AI agent sort of guide you through the tutorial. Right, so it basically acts as a goal for the player to aspire to. Now, in terms of techniques for AI as role model, these are going to be typically done with scripting, so pre-programmed sequences of states in a state machine. But you could imagine sort of any decision-making technique being used for an AI role model. So for an FSM or a B tree, it'd be a typical solution, right? It gives a designer the most control. But you can imagine maybe, okay, so we talked about you don't want to use an optimal player when it's a competitor of the game, because the player will never beat that optimal player. But maybe you could use an optimal player as a goal for the player, right? As like an in-game instructor. Now, this doesn't get around the problem with a lot of these, very powerful automated game playing techniques of weird behavior, but maybe you can get rid of that in the story of the game. Say, it's a Yoda situation, and he's gone a little bit mad over being years of being stuck in a swamp or something. Who knows? So for a reinforcement learning or a deep neural network approach, we could train our role model beforehand so that it plays the game optimally. I don't know why that says personally. And then ship it with the game pre-trained. So then in terms of the impact on the player experience, obviously this is going to impact player goals. It gives the player an embodied entity or a goal to match in their play. And then in terms of role play, so in a lot of role-playing games, having a teacher-type figure can be partnered with a design and narrative that engages the player into the world. So in Skyward Sword, one of the not super popular Legend of Zelda games, you have a tutorial section where you have a tutorial agent that ends up being directly related to the main character, Link. And then similarly in Final Fantasy X HD, while this character doesn't actually have any specialized AI going on with him and you even control him, you do have a sort of mentor-esque figure, and you have these kinds of experiences because of that. Okay, so the third one of these was AI as Trainee, with the examples being Creatures from 1996 and Creatures 2 from 1998 right here. So Creatures, if you weren't familiar, it's understandable if you're not. This is probably well before the majority of y'all's time who are watching this. But Creatures was a game in which you raised and bred these creatures. And the interesting thing going on was actually they were using neural nets for the behaviors of these creatures, which were being trained in the game. Now, this led to all kinds of weird nonsense, but they were relatively popular for a while. Another example of AI as Trainee is the games Black and White and Black and White 2, Black and White 2 from 2005. In it, you played as a god who had an avatar, in this case, this big gold cow, that you would basically train to either perform good actions or negative actions by demonstration and by rewarding and punishing it. Now, notably, there are some rumors that this used reinforcement learning, but actually it just used a decision tree. So the kind of approaches that we talked about for player modeling, right? And then very recently, we have this example, Lab Assistant, which is by Liz Fiacco. You can check it out there. And in this, they're actually using deep neural network natural language processing approaches where your goal is to teach this slime language so that it will accomplish certain scientific tasks. So the reason why this can work is because even though there's all the problems with deep neural networks we've talked about previously, the fact that it's a slime, right, means that we can be okay with the fact that it's going to be wrong a lot. Now, even still, when you're playing this game, it's a frustrating, but also weird and novel and interesting experience. So AI as Trainee, let's talk about this. It's basically the exact opposite of the last pattern. An AI agent is either going to learn explicitly or implicitly by just sort of following along with what the human player is doing from the human player. Player then arises from trying to impact what the AI has learned to accomplish some goal. So there's a lot of techniques that you can use here. Notably, I have a Tamagotchi here, which sort of has training. Really, it doesn't. It's all just sort of pre-authored stuff. There's no learning happening, really. But it's all pre-authored like plans that you can go through, but it gives the impression of training. And then over here, we have Super Smash Bros. Wii U, which had these sort of these amiibo fighters where you could sort of quote-unquote train an AI to act like you, to fight like you in Super Smash Bros. Wii U. Now, this isn't actually how it worked. Instead, what it did is they had a single fighter NPC model, and they would shift some parameters to match whatever your parameters were. However, the sort of average of how you tended to play. These would be things for how often you do certain attacks, things like that. So it's a little bit of learning, right? It has some variables, it has some features in it, updating them, but it's not really that complex of an approach. So the deciding factor in terms of the techniques is that some form of learning must occur. So the very most common thing, like I just gave, is some parameter setting approach, where we have a rule-based system where players' actions impact transition variables of like an FSM, for example. A decision tree, as in like Black and White and Black and White 2, where we could take every player interaction as an example and then learn a tree of what to do from that. And then you could imagine, though this was really only come up in the Lab Assistant example that I linked, you could use something like supervised learning or reinforcement learning, where we take player interactions as either correct answer, the sort of Y that we're trying to predict with our X, or as the reward or penalties. Now, my More AI Maker example from earlier sort of fits both the AI as co-creator and AI as trainee because of this thing. So there is this problem with player experience. So obviously, novelty is a big selling point here, but you can get into this problem where if you haven't pre-specified everything out, right? If you haven't said exactly how these AIs can quote-unquote learn, like a Tamagotchi or a Furby, then they can learn the wrong thing or take too long or frustrate players, right? So either by not meeting the expectations, because an AI isn't going to learn like a human learns, or by learning the wrong thing, where an AI can learn something the player didn't intend. So these are issues, and it's why that you don't see this kind of thing more in big budget games. Okay, the next one was AI is editable. And my example here is actually from Dragon Age 2 from 2011. Dragon Age 2 had you controlling a party of characters, and notably, you could swap out in the options menu how your party would tend to act. So what kinds of moves they would use, things like that. If you've ever played a Kingdom Hearts game, you often have the ability to have some options about how your AI sort of helpers are going to act, your Donald and Goofy or whatever, like whether they use potions and things like that. So this is a way of editing the AI. Also, notably, you can see it in things like Minecraft with custom maps or Galactic Arms Race, where you're changing the heuristic function by how you play. In these kinds of games, the player is going to directly or indirectly alter parameters exposed by the designers. The gameplay then is shaped by the player's choices for these parameters. Editing the AI is not typically the game's focus. It tends to be some extra thing for certain kinds of players. But notably, that still counts for this AI-based game design patterns. So all of the techniques we've discussed this semester have parameters that could be exposed for the players to tune. For heuristic values, obviously you could change the heuristic. For rule-based systems, you could change conditions and effects. For FSMs and B trees, there's transition variables, states, nodes, etc. For planning, you could change the conditions of actions, etc., etc., etc. The hardest one of these would be something like a reinforcement learning approach or a deep neural network approach or a decision tree approach, where while there are parameters, there's not an easy one-to-one for a player to alter. And they would be a lot harder for people who didn't know how they worked to get them doing what they wanted. The impact on player experience is basically that it allows for customization, right? It gives players a way to shape their experience directly and to show off particular parameter sets, right? By saying, ooh, you should try this parameter set, I think it's really good, or this kind of strategy is good with this parameter set, etc. It can also introduce implicit player goals to sort of min or max these settings to create a particular artifact or behavior for their AI agents. Okay, let's take a break. This has been 30-something minutes, 37 minutes, almost 40 minutes of me talking. So quick break for question 1. So AI is editable, and AI as trainee involve directly and indirectly, respectively, altering our AI parameters. Give design goals, so a kind of game that would suggest that you should use AI is editable, and a different set of design goals, a different game idea that would suggest that you should use AI as trainee. Design goals can be in the form of a specific game design or an abstract notion of a desired player experience. Okay, take a couple minutes, give it some thought, write something down, and we'll move on. Okay, that seems like enough time. So here's my answer. So for AI is editable, the design goals include some default artifact, appearance, or behavior, and then the ability to alter the parameters is meant for depth, but it's not an integral part of the base game. So basically, designing with the intent that some players will have a very sort of low interaction with this thing, and other players will get deep into it, what's called like a T-shaped design. And then AI is trainee, something where the narrative and ludic, aka mechanical design of the game calls for like a teacher-student or parent-child-like relationship, right? Okay, so let's move on. So AI is guided was the next one, and the easy example that pops to mind for me, but maybe not for you all, is the Lemmings games. So they originally came out in 1991, and the basic idea was that these lemmings just sort of had very, very simple behavior and would just keep moving forward constantly. They were based on the myth about how lemmings, jump off cliffs all together, will just follow each other to their death. And your basic thing was that you could take control of one lemming very briefly and give them an instruction, one of these instructions down here. And then you had to sort of time it out so you could get all the lemmings from the beginning to the exit. A more recent example would be The Last Guardian, right? Where you are guiding some AI agent, this big old monster, through these sets of levels, while also simultaneously needing to use that AI's specific abilities to be able to get through. So there's lots of, in fact, examples of these. Any sim game basically does this. But essentially, it's a game where the player is going to do their best to guide AI agents to some goal state that they wouldn't reach alone. AI is guided is then going to make up the majority of the gameplay for all of these. Games that make use of this pattern are often referred to as sims or god games, or if they just take up a portion of the game, they'll be called something like escort missions, right? Which are often not really enjoyed, let's say, by the players of their games. That's changed a little bit recently. But obviously the Sim series is extremely long. If you played any Sims game, you've seen these. But back before there were the People Sims, there were things like SimAnt, SimCity, which I think even still exists, which were all about, right, having these little AI agents that you would try to guide towards some goals. In terms of techniques, we need some agents, typically embodied, but they can be something more abstract like, say, a city, which means that we need some decision-making approach. So like an FSM or a B-tree or a rule-based system to do simulation, aka sim, right? So the sims don't really have a lot of intelligence in them, right? Sims 1 through 4, all these little things don't have a lot of intelligence in them. Instead, they have particular rules about how they interact with certain items, and they have a very sort of simple AI to them otherwise. And the real fun of the game is sort of guiding them. Then there's things like ICO. ICO is like a whole game, which is just a escort mission, right? Notably by the same studio as made The Last Guardian, so you can see a through line here. But what if instead we could have a player setting goals for a trained agent, like in the Deep RL example that we had on Wednesday, right? Something where we could set up the player, sort of metaphorically, not as a god, but as like an AI designer. And your goal was to guide this AI towards learning specific things, right? We can imagine all kinds of games like that. Or maybe goals for a planning agent, right? Maybe the game is about, balancing lots of different goals between lots of different agents, or competitive goals, things like that, right? So in terms of the impact on player experience, that's going to be things like player goals. Anyone who has tried to draw a sim knows about the emergent implicit goals that can arise from these systems. So just by having this AI that you can guide, players are going to come up with their own goals, things they want to try to do. Obviously, it's a bit of a power fantasy. The player literally acts as a god for many of these games with all the power that game is allowing them. So hey, quick reminder. We're about halfway through. The second half is going to be much, much shorter than the first half, but just FYI. Now, a reminder that multiple patterns can exist in a single game. So, for example, the Sims series. We have AI is Editable, right? We can recreate our friends and fictional characters. We have AI is Guided, where we want to keep the Sims alive, or the opposite, or try to get the Sims to do certain things. AI is Visualized. Obviously, we can see the internal state. I give examples about that. And then AI is co-creator. We can think about what we get out of The Sims are basically the stories that we can tell about us playing The Sims, right? That's the big fun of it. And the AI is part of that. And then obviously we have a little bit of AI as spectacle, where some of The Sims is just sitting back and watching and seeing what the AI gets up to. Okay, so AI is co-creator. I'm not going to go as much detail here because I did a lot of it up on the top. But there's one example from the paper of Lumen AI, which is a sort of art piece / museum piece where people can dance with an AI. So it's a way of sort of making a dance party with an AI. Notably, it came out of Brian McGurko's lab. So in this, AI agents and the human players work together to produce an artifact, narrative, or experience. And again, I just had a number of examples at the top, so we'll leave it there. Okay, so AI as adversary. The basic thing here is that the AI should have roughly the same sort of abilities, should be at roughly the same level as the human player. So, for example, the Super Smash Bros. Has CPU or CP players, like computer-controlled players, which try to act as close as they can to a real person playing the game to simulate that. You have games like Bloodborne from 2015, where you had other hunters, characters that, according to the narrative of the game, were in the same situation as the player character, and so had the same sort of abilities, and that you'd have to then fight them. Fortnite, notably, which if you don't know anything else about games, you should at least know Fortnite, actually has AI players. So especially in the mobile phone version of the game, a lot of the players you're going to be up against are actually going to be AIs. That's basically to make you feel better about yourself, right? The AIs should die first. Okay, so the basic idea for AI is adversary. Here's an image from Soul Calibur 6. Notably in all fighting games, they basically have this thing, right? We have some symmetric relationship in ability between the players and the AI with some adversarial relationship, right? So they're trying to fight each other, but we have roughly the same abilities. So the idea is that this should create a challenge for the player. Gameplay is then going to arise from the challenge of attempting to beat this enemy AI. The typical techniques are basically the techniques we focused on all the semester, right? So all the decision making, all the path planning, everything where we're trying to have simple computation, which lets us sort of fool the player into thinking that this thing you're up against is a person like you, right? But what if your adversaries adapted to you over the game, right? Or actually had more complex decision making like you do, right? If they could make more global decision makings, if they could path plan and could also plan out their actions, if they could learn as the game went on, you could have all kinds of things happening like that. Okay, so that brings us to AI as villain. So the easy example here is Alien Isolation, which was 2014. If you can't see, there's a xenomorph in that picture there. This game was primarily about running around a space station and being tracked by a xenomorph. We also have an example here of Middle-earth Shadow of Mordor and Shadow of Mordor 2, which had this cool system called the Nemesis system, where basically the idea was that they'd procedurally generate some orcs, and then you would keep on meeting up with the same orc over and over again to create a nemesis for you, right? A villain that followed you around over time. So there's not a lot of specialized AI happening there. Primarily what's happening there is just, a lot of narrative positioning and using the same model once we've generated it. I'll note there's a really good AI in games on Alien Isolation. And then, much more recently, we had the Resident Evil 2 remake with Mr. X, who became a little bit of a meme in terms of, constantly busting in and following players around and stuff like that. Very similar to the Alien and Alien Isolation. Very similar in terms of the way it worked, where it always actually knows where you are, but it sort of pretends it doesn't always know where you are. So, I've given an example here of Untitled Goose Game, where basically the whole game can be thought of as you, the goose, being, I guess, a villain, but that means that the heroes of the game are sort of your villains, if that makes sense, going up against these humans who have more abilities than you do and trying to outwit them. So you basically have an asymmetrical antagonistic relationship between the player and the AI. The gameplay effect is basically the same as antagonistic, but the villain is more of a focus, right? So instead of, you going up against these people who are supposedly at roughly your same level, but are maybe you go across lots of them in the same game, the villain should stand out a bit more as individuals. Typical techniques are, again, going to be decision-making, right? Same as adversary. But we can do the same kind of what if, where, like, what if the AI villain learned and adapted to you over time, right? Now, this doesn't work in quite the same way because the villain should feel like they have more power than you from the jump. So hard to then say, oh, that should be worse later on. But you could still do things like, if you're being chased by a villain, it'd be really scary if that villain started learning about where you tended to hide, right? And then last but not least, we have AI as spectacle. The example that I've given here is the game Everything, which is basically a game where you can quote-unquote become anything, and which has some very, very simple AI, but it's just sort of a game about wandering around and being things. Now, notably, in the original paper, the original authors, Mike and the gang, couldn't think of a single specific example for this one, but it's basically any time you just want to sit back and watch the AI go rather than play the game. So we already talked about how we can think of The Sims as having an aspect of AI as spectacles. The techniques, besides, the ones we've talked about in class so far, are really unclear because there's not a specific example in the paper of what they think of as AI as spectacle techniques. But anytime that we've got some really interesting and complex things going on that we just want to sit back and watch, we can think of that as an AI as spectacle. Like maybe the Dota 2 players and the StarCraft players, where it's not something that you'd want to play against, but it's fun to watch other people play against them. Okay, so that brings us to the end of these patterns. And what's left is ways to think about these patterns, right? So one way is to think, how common is this pattern in games? Well, adversary, guided, and visualized are all pretty common, right? There's whole genres about guiding things in terms of The Sims. Adversary shows up in any game that has like competitive challenges like that with AI. And visualize is also very common because you want to show the internal state of the AI. It's just good game design. Then we have villain, editable, and trainee. So less common for all of these, but still they occasionally show up. I could point you to a few examples. And then co-creator and spectacle, where co-creator doesn't really show up strongly in any particular, AAA or indie games, but is more of a research thing. And same thing with spectacle. Very few examples, if any. Note that this ranking is not absolute or objective, and it's really only existing here to give you a sense of where these things tend to show up in games and how often they tend to show up in games relative to one another. Another way to think about these patterns is how integral is this design pattern to the overall game design. So guided, co-creator, villain, adversary, and spectacle, the games basically wouldn't be the same if the thing that made the use of these patterns show up wasn't in the game anymore. Versus visualized, role model, trainee. The game could continue in some form without it, but it's not nearly as impactful maybe. And lastly but not leastly, we have editable, where many players are just never going to see these aspects of the game. So using the patterns, we can think of basically two major approaches. One would be prescriptive. So that'd be asking the question, what happens if we use ABC and AI techniques XYZ? What kind of game do we get? Right? So it's a way of thinking about the implications of particular uses of particular games in particular ways, right? Or particular AI approaches in particular ways in particular games. And then the other way is descriptive. So we can talk about it like a common language to talk about different game designs and their commonalities. So saying things like, what do The Sims and Resident Evil 2 have in common? Okay, so that brings us to our second and final question. What I want you to do is pick 2 or 3 design patterns and 1 or 2 AI techniques, and give me a high-level concept for a game, right? So pick 2 or 3 of these and 1 or 2 of the AI techniques that we've talked about all semester, and think about how you could combine them to give a high-level concept for a game, okay? Take a couple minutes, again, give this some thought, and then we'll talk about it. Okay, that seems like enough time. So here's my answer. Several years ago, Alex Zook, the Unity guy who was a Blizzard guy, and I made a prototype for a game about creating your own ecosystem, where the goal would be for the player to indirectly, so AI is Trainee, and directly, AI is Editable, alter species in their ecosystem. The basic idea was that members of species would run on a unique finite state machine, and the whole thing would run on a genetic algorithm, where the genetic algorithm optimized both the physical characteristics of a species and the FSM itself, so changing both the appearance and their behavior of these things, these species, over time. We made a little prototype, but it didn't get any further than that. Okay, so during the last class in the chat, somebody asked to see my cats. So this is technically the end of the lecture, but if you want to see my cats, I will introduce them to you. Okay, so first off, we've got Vincent Van Gusdile. That's his whole legal name. He's an orange and white fool. He's also an orange and white floof. And here's a video of him trying to eat my significant other's computer.
Did you get it? Did you get it? Nope. Is it dead, Vinny?
What an idiot. It's okay, we love him. And then we have Goo, who is our black and white princess cat. She is much, much smarter than her fool of a sibling. All right, here's a video of her.
Hey, baby. Hello. Hello. Easy go, baby. Easy go, baby. Easy go, baby. Easy go, baby. Easy go, baby.
Okay, hopefully that was fun for you all. All right, so this is it. We've reached the end of the Game AI lectures. I just wanted to say a quick thank you. Times are weird right now. We've all had tragedies, I think, in these last, few weeks. All of different sizes and shapes. This is not to diminish anybody's suffering right now. So I wanted to say thanks for following along with this, and I wish you all nothing but the best. All right, goodbye.